Hello all. Today we will look into architecture modeling, C4 model. In construction industry, to visually communicate the architecture of a building, you will be presented with site plans, floor plans, elevation views, cross-section views, electricity view, and detailed drawings. But if you see in software industry, in contrast, if you ask a software developer to communicate the software architecture of a software system using diagrams, and you will likely get a confused mess of boxes and lines, inconsistent notation, color coding, shapes, line styles, etc., all in ambiguous fashion, unlabeled relationships, generic technology, terminology, missing technology choices, mixed abstractions, etc. So to address this, we will work on C4 model to get a better architecture in software industry. So why and what is C4 model? The C4 model was created as a way to help software development teams describe and communicate software architecture both during upfront design sessions and when retrospectively documenting an existing code base, that is through reverse engineering. It's a way to create maps of your code at various levels of detail. In the same way, you would use something like Google Maps to zoom in and zoom out of an area you are interested in. So basically, C4 will allow you to zoom in and zoom out of the architecture detail. Architecture maturity model. So, architecture maturity model starts with initial, where there is no architecture at all, and ad hoc architecture diagrams with ad hoc abstractions. It's a general purpose, but it is not defined abstractions. And defined architecture diagrams with defined abstractions, but is again a general purpose. Then comes modeled architecture diagrams with defined abstractions in a modeling tool authored manually. And then comes the optimizing architecture diagrams with defined abstractions in a modeling tool shared between teams for optimizing the models. They become answers for the queries in architecture for any question that may come up, and they can be automatically generated from source code, deployment diagrams, environment, and logs, etc. So C4 model starts from defined. So it evolves from defined to modeled to optimizing. It is optimizing, not optimizing, because it's a continuous process. So you can see the same thing here. Level 1 is initial, where there is no architecture at all. In ad hoc, there is architecture with ad hoc abstractions, notations. It's a general purpose diagramming tool. And then comes with level 3, which is defined, where we have some architecture diagrams with defined abstractions in a general purpose diagram tool as well. But abstractions are defined here. Level 4, the modeled software architecture diagrams with defined abstractions and notation in a modeling tool. The difference is in a modeling tool from defined to modeled. And those are authored manually. But whereas optimizing model elements that are created already till here, this point of model, are shared between teams for optimization across the organization. And models are used as queryable datasets. It can answer the questions in the architecture. And the difference here in modeled and optimizing is another thing where you can automatically generate the model elements from your source code, deployment diagrams or environment diagrams, and then logs, etc. So the C4 model. C4 model stands for context, container, component, and code or class. Context is the system that we are going to develop, and every system has containers in it, and each container will have some components in it, and every component will have code base attached to it. So we'll see that in this diagram. So this is the software system which we are going to develop. This is the context, and then it has several containers like client side web app, server side web app, console application, etc. And this container will have components. Each component will have some responsibility to do, like payment gateway or accounts or statement. And then, so those are the components. And each component will have their own code bases, their controllers. It comes to the code, real code. A software system is made up of one or more containers. So system has one or more containers, which are applications, which are such as server-side web app or console application, and databases, each of which contains one or more components. There are more components, payment gateway, accounts, statements, which in turn are implemented by one or more code elements like classes, interfaces, objects, functions, etc. All the controllers you see in your code.